Okay guys, so we'll be seeing some more examples on the Lee-Chatelier principle. So let's get started. So we have AG plus BG going to form CG and DG, and concentration at equilibrium of the following gases was each having 2m concentration. Okay, and obviously then Kc would be 1, and now if V final is done V initial by 2, then we can say that new concentration at this point of time would be for each of the gases would be 4m. Okay, and the resultant activity would still be 4 into 4 divided by 4 by 4, so that's is still going to be 1. So the equilibrium state is still maintained even if we actually half the volume of the container. Next example is we have Ag plus Bg getting converted into Cg. So here Kc is, let's suppose, equilibrium concentration of the following gases was 1, all having 1 m. And now if we do V final as V initial by 2, then concentration of each gas increase or doubles. So Qc here would be nothing but concentration of gas C divided by concentration of gas A into gas B. So concentration of gas C is 2 divided by 2.2, so that would be half. Qc would be half. Now as Qc is less than Kc, Kc here was 1 initially, so what will happen is equilibrium shifts in forward direction. This implies equilibrium shifts in forward direction. Okay, so let's suppose at new concentration, what happens at new equilibrium, what happens is this is 2 minus x, this gets again 2 minus x, and 2 plus x of C is formed. So this is obviously greater than 1m. Okay, and we know that Kc would be equals to 2 plus x divided by 2 minus x to the powers 2 minus x squared, where obviously x is between 0 and 1. So the Kc value we know from initial equilibrium is 1, so you just have to equate 2 plus x to 2 minus x squared. So this forms a quadratic equation, so you can solve for quadratic equations using the same. Next, let's say we have addition of inert gas into the reaction mixture. So what happens on the addition of inert gas? So let's suppose the gas is added at constant volume. So at constant volume, what happens is if the addition of inert gas is at constant volume, then actually there would be no effect. And why would there be no effect? As the molar concentration of every gas remains constant. Molar concentration of every gas remains constant. Okay, and B, if we add the inert gas at constant pressure, then what will happen? Then again we see that if delta Ng equals to 0, then it would be no effect. And second, if delta ng is positive, then equilibrium will shift in forward direction. And why is this the case? Because as P is constant and PV equals to nRT, this implies that we are adding the inert gas, so we are increasing the N here of the overall mixture, so this implies V is also increasing. Okay, and P would, and as the V is increasing, the concentration of the products, or the overall concentration of every gas would actually decrease. So we can say that QC goes below Kc level, hence the reaction goes in forward direction, or rather equilibrium shifts in forward direction. And third is, if delta Ng is negative, then just opposite of that, that means equilibrium shifts in backward direction. Okay, so with this we come to the end of this lecture. We'll be taking all these concepts again in the next lecture as well. Okay, so in case you have missed out, we will take that again in the next lecture as well. So till then, good luck and goodbye.